Dear students, welcome to this YouTube channel, Physics Sphere, and this is Prasajit Malik, PGT Physics teacher of Kendra Vidyalaya. Today we will discuss about chapter number 12, that is atoms. So this video is very helpful for Cbse students because I will follow strictly the Cbse syllabus. And you can see on the screen, I have given the Cbse syllabus. So let us first see the syllabus. Okay. So what are the topics that are in our syllabus? First you can see here alpha particle scattering experiment. So we will study first alpha particle scattering experiment, which is basically Rutherford experiment. But popularly known as Rutherford experiment, though the experiments were performed by Geiger and Marsden. But Rutherford given the mathematical model. Basically that was the thought experiment of Rutherford. But Geiger and Marsden actually performed the experiment. Then we will discuss about the Rutherford's model of atom, which is basically the outcomes of Rutherford experiment. Then we will discuss about Bohr model of hydrogen atom. We will discuss about expression for radius of nth possible orbit, and we will discuss about velocity and energy of electron in nth orbit. Then we will discuss about hydrogen line spectra, and here you can see qualitative treatment only. That means we will not going to the rigorous mathematics. Okay. So first topics that we have, alpha particle scattering experiment. So what this experiment actually say? This experiment actually say if you throw alpha particles from the source if we throw alpha particles, so most of the alpha particle will pass through this gold foil, and there are very few particles which you can see here and here that will scattered here and here. So here you can see this bright spot. This bright spot suggests that most of the alpha particles will strike here, and there are very few alpha particles which will come back or which will scatter back, you can say. And how many number will scatter back at a particular angle, that mathematical model was given by Rutherford. But this experiment physically done by Geiger and Marsden. So we have to see the mathematical expression, the dependency of number of alpha particles that will scatter at an angle theta. So Rutherford basically mathematically proved that the number of particle, that is n of theta, which will scatter at an angle theta, is directly proportional to 1 upon sine to the power 4 theta by 2. So this was basically the outcomes, mathematical outcomes of Rutherford model. And when Geiger and Marsden performed the experiment really, they will see that there are very few number of alpha particles which will scatter back, and that will actually suggest by this equation. How you can see, if you draw the curve between n of theta and theta, then you can see if you draw the curve n of theta versus theta, then you can see it will be 1 upon sine to the power 4 theta by 2. That means if theta increase, n of theta decrease. So it will be something like this. So this will be the curve. So what it actually means? It means the number of particles decrease when theta increase. That means there are very few particles which will scatter at an angle theta. So what it physically means? It physically means that most of the alpha particle will pass as it is. They will follow straight line path. That means that they will deflect very little. Otherwise, they do not reflect back if they do not scatter. They will pass as a way along straight line. So that means most of the space inside the atom is empty space. So that is the main outcomes. But you can see a very few alpha particles, say 1 alpha particles out of 20,000 alpha particles will exactly scattered back. That means they will scatter at an angle 180 degree. And you can see here from this equation, you can see it will also suggest the same thing. If you put here theta is equal to 180, then what you will get? You will get 180 upon 2, that is theta upon 2, that will be 90, and sine 90 is 1. So n of theta is obviously proportional to 1. So this means proportional to 1 means there is some constant term also. It means this is close to 1. So there are very few alpha particles which will reflect back, and in number approximately that is 1 out of 20,000. So you can say कि only a very few number of mass, a few amount of mass concentrated at the center, so that it will basically scatter the alpha particle. Otherwise, most of the space are vacant, where the particles will easily pass. So Rutherford concluded that inside the atom there is a very smallest region where most of the mass and positive charge concentrated of the atom, and that is called nucleus. And this is the most dense material. You can second most dense material in the universe after black hole. Black hole is the most dense matter till now we have in our hand, or you can say till now it was discovered that black hole is the most dense material, and after black hole the density of the nucleus is more. मतलब न्यूक्लियस जो है ये सेकंड पोजीशन में आते हैं with respect to density, and we will calculate the density of nucleus in the chapter nucleus in the next chapter, that is chapter number 13 according to Cbse syllabus. Okay, so this is basically the outcomes of the Rutherford model. Now the question is that where electron will be inside the atoms. Electron भी तो होना चाहिए. We have performed the experiment and we have come to know the positive charge is at a particular region, that is basically protons, and later neutron was also discovered, and वो भी पाया गया है कि न्यूट्रॉन भी वो न्यूक्लियस के अंदर ही रहता है. But where electrons will reside, so in that case Rutherford formulated a model, atomic model, that will tell, the postulates of Rutherford models will tell कि how protons and electrons and neutrons will be inside the atoms. Okay, so this is basically the Rutherford's atomic model. Now what are the postulates of Rutherford atomic model? This is also a very important thing. And the first postulate that I have already discussed, कि dense positively charged nucleus, so ये dense positively charged nucleus के बारे में बताता है. That is, nucleus is concentrated, मतलब positive charge is concentrated at a small region which is called a nucleus. So Rutherford proposed that the atom has a small dense and positively charged nucleus where most of the mass is concentrated and the rest of the atom is mostly empty space that I have told you. So this is the first postulates of Rutherford atomic model. So second postulate क्या होना चाहिए? Where the electron will reside. So second postulate Rutherford से कि electrons revolve around the nucleus. इसका मतलब इलेक्ट्रॉन जो है वो न्यूक्लियस के आसपास चक्कर लगाएंगे. So if here is a nucleus of positive charge, then electrons will move in this way. So how Rutherford think this? This is the very simple logic कि अगर ये पॉजिटिव चार्ज है और ये नेगेटिव चार्ज है, so positive charge will attract the negative charge. So negative charge empty space में रह नहीं सकता. So if this negative charge is static here, then it will attracted by the nucleus and the electron will fall on the nucleus. So the structure of atom will be destroyed. So a very simple logic he applied. If the electron revolves, then he will get a centripetal force. So that centripetal force will use here to revolve the electron. And if you talk about in the frame of electron, then you can understand this thing by the centrifugal force. कि electron जो है that will rotate in a speed v, and if it will rotate with a speed v, then a force, that is centrifugal force, will act outwards, and the magnitude of this is mv square upon r. You have already studied in your circular motion chapter. And if there is a electrostatic force along the nucleus, so these two forces, this electrostatic force Fe and this centrifugal force, will balance the electron. So there will be a radial equilibrium and the electron will rotate around the nucleus. So for each and every electron the same logic is applied and the atom will be stable according to Rutherford model. So this was basically the Rutherford model. But the problem arises when Maxwell's electromagnetic theory was discovered. So if you talk about the Maxwell's electromagnetic theory, then that theory does not allow not electron, any charged particle. According to Maxwell electromagnetic theory, when a charged particle will accelerate it, that will radiate energy. So if the electron revolves around the nucleus, it will continuously radiate energy, and that's why its energy will be at last will be zero. The energy will be finished and it will drop into the nucleus. So according to that theory, that classical electromagnetic theory, the Rutherford model was not a stable model of nucleus. So here drawbacks of Rutherford's models are come. So what are the drawbacks you should know about the Rutherford model? So first drawbacks that I have already told you, inability to explain atomic stability. That means according to classical electromagnetic theory, electrons revolving around the nucleus in circular orbits would continuously lose energy by emitting radiation. This would cause the electrons to spiral into the nucleus. इसका मतलब क्या है, ये जो इलेक्ट्रॉन्स जो घूम रहा था, ये ऐसे ऐसे स्पाइरल पाथ में ये आकर न्यूक्लियस में गिर जाएगा, मेकिंग द एटम्स अनस्टेबल, व्हिच डज नॉट हैपन इन रियलिटी. बट इन रियलिटी ऐसा नहीं होता है. इलेक्ट्रॉन स्टेबल होता है, इलेक्ट्रॉन रिवॉल्व करता है और वो स्टेबल भी होता है. बट Rutherford's atomic model cannot explain that thing. And one more thing that Rutherford cannot explain, the Rutherford atomic model cannot explain, and that is the lack of explanation of atomic spectra. जो लाइन स्पेक्ट्रा है हाइड्रोजन एटम का, है ना, वो भी डिस्कस नहीं कर पाया. So Rutherford's model could not explain the discrete lines observed in the atomic spectra. Actually, according to classical theory, वहाँ continuous spectra दिखना चाहिए था, but they will show in reality they show the discrete lines of elements which indicated that electrons occupy specific energy levels. But if you talk about classical theory, अगर इलेक्ट्रॉन्स ऐसे सर्कुलर पाथ में घूमते रहते हैं तो कंटिन्यूअस एनर्जी रेडिएशन देना चाहिए था. बट हियर डिस्क्रीट एनर्जी लेवल दे रहा है. इसका मतलब कहीं ना कहीं एनर्जी जो है ये क्वांटाइज्ड है. सो दैट विल प्रपोज्ड बाय बोर्स मॉडल. Okay, so that's why we need another model of atom that is called Bohr's model. Okay, so let us see about the Bohr model. So now let us first see the postulates of Bohr models. What are the postulates of Bohr model? So पहले Bohr model क्या बताता था, जैसे वहां जो प्रॉब्लम था Rutherford मॉडल में, बेसिकली जो प्रॉब्लम था दैट इज इलेक्ट्रॉन्स जो है वो एनर्जी रेडिएट करते हैं. क्योंकि क्लासिकल इलेक्ट्रोमैग्नेटिक थ्योरी जो है that will suggest a accelerated charge particle will radiate energy. But actually इलेक्ट्रॉन जो है वो क्लासिकल पार्टिकल है ही नहीं. इलेक्ट्रॉन जो है वो बेसिकली क्वांटम पार्टिकल है, एंड फॉर द क्वांटम पार्टिकल इट शुड नॉट हैपन. यहाँ एनर्जी तब रेडिएट होता है जब ये एक एनर्जी स्टेट से दूसरे एनर्जी स्टेट में जंप करेगा. सो इसलिए इलेक्ट्रॉन्स को एक क्वांटम पार्टिकल याद रखते हुए बोर एक नया मॉडल दिया है. लेकिन बोर्स मॉडल में जो बेसिकली यूज हुआ था दैट इज एंगुलर मोमेंटम, क्वांटाइजेशन ऑफ एंगुलर मोमेंटम, एंड द टर्म एंगुलर मोमेंटम इज बेसिकली अ क्लासिकल टर्म. सो एक क्वांटम पार्टिकल के ऊपर बोर एक क्लासिकल पार्टिकल्स का जो प्रॉपर्टी होता है वो यूज किया था, एंड ही सक्सेसफुली गिवन अ सैटिस्फैक्टरी मॉडल ऑफ एटम अप टू दैट टाइम. बट बाद में वो भी मॉडिफाई हुआ, लेकिन अप टू दैट टाइम बोर ने इलेक्ट्रॉन को ना एक क्लासिकल पार्टिकल माना था और ना एक क्वांटम पार्टिकल माना था. ही assumed electrons as a semi classical particle. So we will discuss this Bohr model keeping in mind electron is a semi classical particle. So what are the postulates of Bohr model? Let us first see. First of all is stationary orbits. That was not mentioned by Rutherford. स्टेशनरी ऑर्बिट का मतलब क्या है, इलेक्ट्रॉन्स जब एक ऑर्बिट में घूमेगा तब इलेक्ट्रॉन्स का जो एनर्जी है वो रेडिएट नहीं होगा, वो एक पर्टिकुलर ऑर्बिट के लिए उसका एनर्जी जो है वो फिक्स्ड होगा. दैट मींस एनर्जी इज फिक्स्ड एट अ पर्टिकुलर ऑर्बिट एंड दैट ऑर्बिट इज कॉल्ड स्टेशनरी ऑर्बिट. एंड एनर्जी तब रेडिएट होगा या फिर एब्जॉर्ब होगा जब इलेक्ट्रॉन जो है वो जब जंप करेगा, एक स्टेट से दूसरे स्टेट में जाएगा. So that was the first postulate कि an electron revolves around the nucleus in a certain fixed circular path. called stationary orbits or energy levels without radiating energy. These orbits correspond to specific energy levels. They are corresponds to specific energy levels. And second thing that I have told you कि क्वांटाइजेशन ऑफ एंगुलर मोमेंटम. इसका मतलब ये जो सर्कुलर पाथ है, ये सर्कुलर पाथ का रेडियस ऐसा नहीं है कि इलेक्ट्रॉन्स रैंडमली कोई एक रेडियस पाथ ऑक्यूपाई कर लेगा. उसका जो रेडियस होगा वो एक सर्टेन रेडियस होगा. मतलब वो रेडियस ऐसा होगा कि उसका जो एंगुलर मोमेंटम वो क्वांटाइज्ड रहे. वो कैसे क्वांटाइज्ड रहे? द एंगुलर मोमेंटम ऑफ एन इलेक्ट्रॉन इन स्टेशनरी ऑर्बिट क्वांटाइज्ड एंड इट इज गिवन बाय mvr. If you talk about the angular momentum, which is a classical term, and basically the definition of angular momentum is simply mvr. mv is the momentum, and if you multiply with the radius to mvr, this is angular momentum, and that should be equal to n into h upon 2 pi, where h is the Planck constant. You know, here देखिए n एक नंबर है, where you can write n is equal to 0 1 2 3. ये n एक नंबर है, और mvr जो इसको हम l से भी रिप्रेजेंट करते हैं कभी कभी, एंड दैट विल बी n into h upon 2 pi. हियर h क्या है? h बेसिकली Planck constant. A very important role will play this h. h is Planck constant, which is equal to 6.626 into 10 to the power minus 34 joule second. Okay, so this is l. This is l. l is equal to n into h upon 2 pi. So r ऐसा होना चाहिए कि mvr जो है that will be equal to nh by 2 pi. अदरवाइज कोई रैंडमली r ये नहीं ऑक्यूपाई कर सकते हैं. मतलब कोई भी ऑर्बिट में किसी भी रेडियस का ऑर्बिट में इलेक्ट्रॉन जो है नहीं घूम सकता है. सो इलेक्ट्रॉन विल मूव in a circular orbit, in a certain circular orbit which have angular momentum mvr equal to n into h by 2 pi. Okay, so next, that last postulate that is more important, that is energy emission or absorption. So an electron absorbs or emits energy only when it transition between two energy levels. That I have already told you कि ये एनर्जी तब रेडिएट करेगा जब ये एक स्टेट से दूसरे स्टेट पे जाएगा. द एनर्जी डिफरेंस बिटवीन दिस लेवल्स इज गिवन बाय, सपोज हमारे पास दो लेवल है. वन इज द लेवल n1 इनिशियल, यू कैन से ni, एंड अनदर इज द nf. सो व्हेन इनिशियल लेवल से फाइनल लेवल तक जाएगा, सो इट विल रेडिएट एनर्जी. ओके, सो सपोज, और ऐसे तो ये एब्जॉर्ब होगा, तो देखिए हम इसको ऐसे रिप्रेजेंट करने में अच्छा होगा क्योंकि ये हायर एनर्जी से जब लोअर एनर्जी स्टेट में आएगा. सपोज दिस इज आवर इनिशियल लेवल ni and this is our final level nf. So when electron will jump from initial state to final state, it will radiate energy, and that will be equal to h nu, where again h is Planck constant and nu is the frequency. So if you write the energy of this state is eni and this is enf, so it will be just if in final minus initial is equal to h nu. So this will be your quantized equation for this postulates. Now by using these postulates and using these postulates, we will discuss some mathematical term basically, where the first thing is the radius of n possible orbit. Suppose this is the nucleus, the charge of the nucleus is Jd, so it is obviously plus Jd, and electron which have negative charge is revolving around the nucleus. So suppose this is the path orbit of this electron, and the radius of this nth orbit will be Rn. So let us suppose that it is Rn. Now we have to find out the expression of Rn. Now what are the force acting on the electron? One is centrifugal force. If the electron is moving with speed Vn, which is speed in nth orbit, so it will have mvn square upon Rn. So this is a centrifugal force, and here in this direction there will be the electric force. Now at radial equilibrium, you can write that is at radial equilibrium, inside force, that is Fe, that will be equal to outside force, that is mvn square upon Rn. Now what is Fe? Fe is the simple electric force. So two charge particles Jd and minus E are separated at a distance Rn. So it will be just by using simple Coulomb's law, we can find out that will be 1 upon 4 pi epsilon naught into Jd into E. upon Rn square, and that will be equal to mVn square upon Rn. So from here we can find out Rn, but we will use another more thing, that is the angular momentum quantization. So how you can find? So let us first modify this. So if you cancel this Rn with one Rn here, so we have mVn square into Rn. If we do the cross multiplication, and you will get 4 pi epsilon naught also. So 4 pi epsilon naught Rn into mv, that is equal to z square. So basically we can write in this way also, mVn square Rn equal to z square upon 4 pi epsilon naught. Now you can see this is mVn square and Rn. So if you multiply m and Rn, so what will happen here? If you multiply both side m, then it will be m square Vn square, and if you multiply Rn, so it will be Rn square. So it will be just z square mRn upon 4 pi epsilon naught. Now you know कि according to angular momentum quantization, we have already this mvr, that means mvn Rn equal to n into h upon 2 pi, where n is 1 to 3. Okay, so now if you put this value here, you will get just n square h square upon 4 pi square, that is equal to z square m Rn upon 4 pi epsilon naught. Now from here we can find out Rn. So what will be Rn? Okay, so if you again cross multiply, so you will get 4 pi square z square m into Rn equal to 4 pi epsilon naught into n square h square. So from here you can find out Rn, which is nothing but 4 pi epsilon naught into n square h square upon 4 pi square z m square. Okay, 4 pi square z m square. So this is the expression of a radius of nth possible orbit. Okay, now you can find out from here directly, that is Rn is proportional to n square, and this is very important. Now if you talk about a hydrogen atom, for that case z is equal to 1. So if you talk about the nth orbit of hydrogen atom, so in that case it will be simply modified, because z is 1 in that case, so it will just 4 pi epsilon naught into n square h square upon 4 pi square m square. Now for hydrogen atom fast orbit, so hydrogen atom का fast orbit के लिए क्या होगा? For n is equal to 1. So in that case it will be just r1 of h. This is sometimes written as a0. This is the radius of fast orbit, and that will be basically 4 pi epsilon naught into h square upon 4 pi square m square. Now if you see, if you want to write this expression in terms of a0, so what you can write? You can write Rn of h is equal to basically n square into the term here is that a0. So this is a0, and if you put the value here, the value of h, you know according to various information, that you have Planck constant. The Planck constant, you should remember actually this values, that is 6.626 into 10 to the power minus 34 joule second. Okay, and the value of pi, and mass of electron 9.11 into 10 to the power minus 31 kg. Similarly the mass charge of electron is 1.6 into 10 to the power minus 19 coulomb, and if you put this value here, you will get a value that is 0.53 angstrom in angstrom. Angstrom means that is 0.53 into, you can write 10 to the power minus 10 meter. So this is the radius of the fast Bohr orbit. So sometimes we can write these things, a radius of nth orbit of hydrogen atom, that will be just 0.53 into n square angstrom. So you can remember this thing in this way also, instead of remembering this rigorous mathematics. Okay, so you should remember that Rn of hydrogen atom is proportional to n square into n1. But in general you can see there will be z also. in general there will be z also. So in general इस equation को हम कैसे लिख सकते हैं? In general this Rn can be written as n square into a naught upon z. So this is the general equation for nth the radius of nth orbit. Okay, general इसका मतलब है besides hydrogen, if there is any one electron system, for example if you talk about the helium, हाइड्रोजन के बाद अगर आप हीलियम की बात करते हैं, there is helium plus. So in helium plus you can see there is also one electron, but in that case z is equal to 2. So in this expression, for if you talk about the nth orbit of helium plus, so in that case Rn of H plus, so that will be just n square a naught upon 2, because z for helium is 2. Similarly you have more than you have a lot of you can get another one electron system also, that is lithium 2 plus. So in lithium 2 plus this is also one electron system. One electron system का मतलब ये है कि outer orbit में एक ही इलेक्ट्रॉन रहेगा. So for lithium also we can find out this is one electron system, but z is 3 here. So in this way in general we can write in terms of z, but for hydrogen atom obviously z is equal to 1, so we can write this formula. Okay, so this is how we can find out the radius of nth orbit. Similarly we can find out the expression of velocity of electrons in n possible orbit. Okay, so what is the velocity of electrons in n possible orbit? So we have already in our hand Rn, so we can use that expression obviously. So पहले हम Rn का जो expression है वो लिख लेते हैं. So Rn is basically 4 pi epsilon naught, you can see, into n square h square upon 4 pi square m z square. And you can see I am not cancel out this 4 pi and 4 pi because we know the value of 4 pi epsilon naught. ये हमको पहले से पता है कि 4 pi epsilon naught का वैल्यू क्या है. You know in your electrostatics कि 1 by 4 pi epsilon naught जो है that is basically 9 into 10 to the power 9. So 4 pi epsilon naught क्या होगा? 1 upon 9 into 10 to the power 9. So this is basically a known value. That's why I am not going to cancel this 4 pi and 4 pi square. Okay, so this is the expression of Rn. ये फिर nth possible radius of nth possible orbit. Okay, now if you want to find out the speed of the electrons in nth possible orbit, then you have to use the expression obviously for angular momentum quantization. So that expression was m into v1. Here m is the mass of electron, you know, I think, into Rn, and that is equal to n into h upon 2 pi. Now from here you can find out vn. So vn क्या होगा? So vn equal to nh by 2 pi into, you can see there will be m and 1 upon Rn. So in this expression 1 upon Rn you can substitute this. So if you substitute this, what you will get? You will get just nh upon 2 pi m into, it will be just reciprocal of this, so 4 pi square m z square upon 4 pi epsilon naught into n square h square. Now what will happen here? So here 2 pi and 2 pi will cancel out, so 4 pi square, 1 m will also be cancelled out, and 1 nh will also be cancelled out. So it will be just 1 upon 4 pi epsilon naught into 2 pi z square upon n square nh, upon nh. So you can see the speed of the electron in n possible orbit is directly proportional to 1 upon n. So you can see from here Vn is directly proportional to 1 upon n. Now how we can modify this expression again for hydrogen atom, and in terms of the speed of hydrogen atom we can express the expression for other atoms also, but the atoms should be one electron system. Now this is basically a limitation of Bohr model. You can say Bohr model is only applicable for one electron system. Now for hydrogen atom what will happen? For hydrogen atom you can write Vn for hydrogen, so that will be basically there will be 1, so it will be 1 upon 4 pi epsilon naught into 2 pi square upon nh. Now for n is equal to 1, that is for first orbit of hydrogen atom, so that will be v1 of h, so that will be 1 upon 4 pi epsilon naught into 2 pi square upon h. Now again you can see, you can write the value of h, e and 1 upon 4 pi epsilon naught So you will get a value that will be c upon 137. You should remember this. Here c is basically the speed of light, which have value 3 into 10 to the power 8 meter per second. So you can use this expression to remember the main expression. So now if you want to modify this expression, देखिए इस expression को अगर हम modify करना चाहते हैं तो you can find out easily from here. So Vn क्या होगा, देखिए z and n को हम अलग कर देंगे. So from here you can write Vn equal to 1 upon 4 pi epsilon naught into 2 pi square upon h into z upon n. एंड ये z upon n को अगर हम छोड़ देते हैं तो ये जो वैल्यू है दैट इज दिस, देखिए, एंड इसका जो वैल्यू है दैट इज c upon 137. सो वी कैन इजीली सब्स्टिट्यूट हियर c upon 137 into z upon n. सो इसलिए इन जनरल हम स्पीड का जो एक्सप्रेशन है इसको हम ऐसे लिख सकते हैं into z upon n. But basically what you have to remember that Vn is proportional to 1 upon n. So this formula we will use again and again, especially for numerical purpose. Okay, so now we will find out the energy of electron in nth possible orbit, and obviously energy means the kinetic energy as well as the potential energy. So what will be the kinetic energy and what will be the potential energy? So we have already find out the speed of nth possible orbit is Vn. So kinetic energy of electrons you can easily write that will be just half m Vn square. Okay, but the speed the expression of Vn also we know, but you can find out easily in this way in terms of Rn. देखिए जो रेडियल इक्विलिब्रियम का कंडीशन था, फ्रॉम देयर वी कैन राइट कि ये जो सेंट्रीफ्यूगल फोर्स था, सो इफ दिस इज न्यूक्लियस and nucleus of the charge Zd, so plus Zd charge is here, and electron जो है that is at a distance Rn. So here electron, and this electron is revolving along this path, suppose with speed Vn. So we have two forces, one is along this direction mvn square upon Rn, and another is direction that is Fa. Now if you equal these two, so you will have mvn square upon Rn that is equal to 1 upon 4 pi epsilon naught into z square upon Rn square. So now if you cancel one Rn and if you multiply half, okay, so it will be just half m vn square equal to 1 upon 4 pi epsilon naught into z square upon twice Rn, and you can see this is basically the kinetic energy. So you can write easily that kinetic energy is equal to 1 upon 4 pi epsilon naught into z square upon twice Rn. So this is the expression for kinetic energy. Now what should be the expression of potential energy? So in case of potential energy you can easily write, because you know from your electrostatics the expression of potential energy, if you write Pe potential energy, that is just 1 upon 4 pi epsilon naught into q1 q2 divided by distance. And q1 q2 क्या है here? Here q1 is plus Zd and Qd minus E. So you can write the expression of potential energy just simply substituting the value of Q1 and Q2, that is Ze and minus E. And you know, I think for to determine potential energy we have to use charges with sign, and here this R is Rn. So it will be just minus 1 upon 4 pi epsilon naught into Z square upon Rn. Now if you add these two, you will get the total energy. So the total energy expression will be very simple. So what will be the total energy? That is kinetic energy plus potential energy, and that will be, so this is the total energy E, you can say En, you can say in nth orbit, and the kinetic energy is 1 upon 4 pi epsilon naught into Z square upon twice Rn minus 1 upon 4 pi epsilon naught into Z square upon Rn. Now if you add these two, you will get just minus 1 upon 4 pi epsilon naught into Z square upon twice Rn. So this is the expression of En in terms of Rn. But if you find out the expression of En in terms of n square, h square, something like this, so you have to put the value 1 by Rn. So you can write from here En equal to minus 1 upon 4 pi epsilon naught into Z square upon 2 into 1 upon Rn. Now what is the value of 1 upon Rn? Again we have to use the expression of Rn. Okay, what we have the expression of Rn. Let me write here again. We have Rn equal to 4 pi epsilon naught, okay, into n square h square upon 4 pi square mz square. So this was the expression for Rn. Now if you put the value of Rn here, so you will get the reciprocal of this, and your En will be minus 1 upon 4 pi epsilon naught into z square upon 2 into 4 pi square m z square upon n square h square I think something is problem here. 4 pi epsilon naught, yes, okay, right, n square h square, and you can see here 4 pi epsilon naught, it will also be in denominator, so we can write this 1 by 4 pi epsilon naught here, so it will be just square of this. Okay, so this is the expression of En. Now if you slightly modify this, you will get 1 upon 4 pi epsilon naught whole square into एक टू कैंसिल कर देते हैं, so 2 pi square m z square e to the power 4 upon n square h square. So this is the expression for En. This is the expression for En, nth possible orbit. Now again, if you want to find out for hydrogen atom, En for hydrogen atom, so what will be the expression? And the expression will be just minus 1 upon 4 pi epsilon naught whole square into 2 pi square m e to the power 4 upon n square h square, n square. But if you talk about the first orbit of hydrogen atom, then it will be just h square. Now if you substitute again the value of 1 by 4 pi epsilon naught e m h, then you will get a very famous expression of E1, that is minus 13.6 electron volt in electron volt. Now if you put this value here, if you use this value here, so if you leave z square and n square, so z square and n square को अगर हम अलग कर लेते हैं, तो ये जो expression आएगा, that expression will be En equal to minus 13.6 electron volt will consume whole the terms z square and n square को छोड़ के, so ये हो जाएगा minus 13.6 into z square upon n square. So this is also the general expression of this total energy terms, minus 13.6 into z square upon n square. And from this expression we can find out the different energy levels for n is equal to 1, n is equal to 2. So for hydrogen atom, basically if you talk about hydrogen atom, देखिए for hydrogen atom क्या होगा, ये जो En का जो एक्सप्रेशन है, और यहाँ से हम हाइड्रोजन स्पेक्ट्रा को भी हम समझ सकते हैं, हम डिस्कस कर सकते हैं. सो व्हाट इज En? देखिए En का जो एक्सप्रेशन है, दैट इज बेसिकली minus 13.6 upon n square into z square. But if you talk about this En for hydrogen atom directly, so it will be just minus 13.6 upon n square, because for hydrogen atom z is equal to 1, you know. Now what will happen here? So if you talk about the first orbit for hydrogen atom, that is E1, you can say, of hydrogen atom, so that will be just minus 13.6 electron volt, and you can see from here, from this diagram, so this is minus 13.6 electron volt, that is for n is equal to 1. Now similarly, if you talk about n is equal to 2, that is E2. Okay, so E2 for hydrogen atom, what will happen? It will be just minus 13.6 upon 2 square, so that will be minus 13.6 upon 4 electron volt, and that will give you this result, that is minus 3.40 electron volt. Similarly, if you talk about E3 of hydrogen atom, so that will be minus 13.6 upon 3 square, मतलब 9 electron volt, and that will give you the minus 1.51 electron volt. Similarly, you will get E4 also for hydrogen atom, that will be just minus 13.6 upon 4 square electron volt, that means minus 13.6 upon 16, and that will give you the minus 0.85, and so on and so on. So this is how you can get the different energy levels. Now how you will get the line spectrum of hydrogen atom? For example, you can see here, suppose the electrons are jumps from second orbit to first orbit. Okay, so if one electron jumps from second orbit to first orbit, इलेक्ट्रॉन अगर एनर्जी लेवल 2 से एनर्जी लेवल 1 में आ गया, तो देखिए ये एक ऐसे एनर्जी रेडिएट करेगा. सिमिलरली इफ इट विल मूव फ्रॉम 3 to 1, it will give also another energy level, another radiative energy. So ये जो देखिए डिस्क मतलब इसका जो फ्रीक्वेंसी है, सपोज ये अगर न्यू वन है, फ्रीक्वेंसी एज न्यू वन, तो ये हो जाएगा एच न्यू टू. सो ये फ्रीक्वेंसी जो अलग अलग फ्रीक्वेंसी है. सो फॉर अलग अलग फ्रीक्वेंसी विल गेट अलग अलग स्पेक्ट्रल लाइन. ओके, सो ये जो लाइन बन रहा है that will come from orbit 2 to 1, 3 to 1, 4 to 1, 5 to 1, 6 to 1. इसका मतलब जितना भी इलेक्ट्रॉन्स जंप कर रहा है, कहीं से भी आ रहा है, इसका जो फाइनल डेस्टिनेशन है that is n equal to 1. And this radiation, this spectra will form a series. You can see form a series, and this is called Lyman series. Similarly, and this series from here, what will be the radiation that is coming from this series? It will lie on UV, मतलब ultraviolet region में ये रहेगा. Similarly, when the electrons will come from any other orbit to orbit number 2, then it will form a Bohr series. Okay, and here this series या फिर ये जो रेडिएशन दे रहा है, ये जो लाइट एमिट हो रहा है फ्रॉम दिस जंपिंग ऑफ इलेक्ट्रॉन्स, यहाँ से हम विजिबल लाइट को देख पाएंगे. सो इट विल गिव द विजिबल लाइट. सिमिलरली if electrons jumps from any other orbit to orbit number 3, then it will give you Paschen series and so on. So and this is on IR region, so infrared. So this is how you can find out the hydrogen spectrum, that is line spectrum. बिकॉज एक ऑर्बिट से जब दूसरे ऑर्बिट में इलेक्ट्रॉन जा रहे हैं, इलेक्ट्रॉन जंप कर रहे हैं, तब एक पर्टिकुलर फ्रीक्वेंसी का वो रेडिएशन देता है. सो एक पर्टिकुलर फ्रीक्वेंसी के लिए एक स्पेक्ट्रल लाइन बनेगा और दूसरा फ्रीक्वेंसी के लिए दूसरा स्पेक्ट्रल लाइन बनेगा. सो इसका मतलब क्या है, वो लाइन स्पेक्ट्रम दे रहा है. सो दिस इज बेसिकली द क्वालिटेटिव आइडिया ऑफ लाइन स्पेक्ट्रम, एंड यू कैन मैथमेटिकली सी व्हाट विल बी द वेवलेंथ फॉर दिस Lyman series, Bohr series and Paschen series. But according to syllabus, we are restricted ourselves here only. Okay, so we have discussed the qualitative phenomena, how this Lyman series, Bohr series and Paschen series can arise. Okay, thank you. And now let us solve some questions on this theory. Okay, so let us solve the first question. So here you can see using the known values of hydrogen atom. सो हाइड्रोजन एटम के लिए जो वैल्यू हमने निकाला था उसको याद करते हुए कैलकुलेट रेडियस ऑफ थर्ड ऑर्बिट ऑफ लिथियम प्लस 2 एंड स्पीड ऑफ इलेक्ट्रॉन इन फोर्थ ऑर्बिट फॉर हीलियम प्लस एंड एंगुलर मोमेंटम ऑफ इलेक्ट्रॉन इन थर्ड ऑर्बिट ऑफ हीलियम प्लस. सो व्हाट वी हैव टू डू, वी हैव टू फर्स्ट राइट डाउन द जनरल इक्वेशन. सो व्हाट वाज द जनरल इक्वेशन फॉर nth रेडियस? सो वी हैव Rn, that is our 0.53 into n square upon z angstrom. So this was actually our result for radius for nth orbit for any atoms, and this 0.53 angstrom is basically for hydrogen atom. So we have used this result for hydrogen atom according to the question. Now what we have to find out, we have to find out lithium plus 2. Now you have to understand what will be the Z for lithium. You know, according to periodic table, पहले हाइड्रोजन आता है, फिर हीलियम, फिर लिथियम. So if this is 1, this is 2, then this is 3. So its atomic number is 3. So what we have to write here, we will get 0.53, and orbit is third orbit. So your n is equal to also 3. So n is 3 and Z is 3, both 3. So what will be your result? 0.53 into 3 square upon 3 angstrom, that will be 1 3 will be cancelled out. So that will be 3 into 0.53 angstrom, and that will be 3 into 3 9, 3 into 5 15. So 1.59 angstrom, or you can say approximately 1.6 angstrom. So this is the radius for lithium atoms in third orbit. Now second, क्वेश्चन नंबर बी में क्या है? दिस इज फॉर क्वेश्चन नंबर ए. ना क्वेश्चन नंबर बी में थोड़ा वेरिएशन है, एटम्स अलग है, हीलियम प्लस है. सो व्हाई इट इज लिथियम प्लस 2 हीलियम प्लस, व्हाई इट इज नॉट लिथियम? देखिए ये जो एटॉमिक नंबर है दैट विल बी फिक्स्ड, बट द नंबर ऑफ इलेक्ट्रॉन in the outer orbit will be different for lithium and lithium plus 2, for helium and helium plus 1, because for helium plus 1 and lithium plus 2 only one electron will be there in the outer orbit. So you can say these atoms are now something like hydrogen atom, they are one electron system, and Bohr theory is always applicable for one electron system only. So हीलियम प्लस के पास भी एक ही इलेक्ट्रॉन है बाहर में, और इसका जो Z है that is 2. Now here as it is said helium, so Z is obviously equal to 2, and this is speed of electron in fourth orbit, so n is equal to 4. Now we have to write down the general equation in terms of the result for hydrogen atom for the first orbit. So in general, what was V? Vn was C upon 137. So this result I have used many times, and this result C upon 137, C where C is the speed of light in vacuum. This is basically for the speed of hydrogen atom in first orbit. Now it have dependency of Z and N also, that is Z upon N. So this is how we can write. Now here we have to write N is equal to 4 and Z is equal to 2. So it will be just C by 137 into Z जो है 2 upon 4. So it will be half. So that will be C upon 2 into 137. So that will be basically C upon 2 into 7 14, 3 into 2 6 plus 1 7. So 274, that is centimeter per या फिर मीटर पर सेकेंड आप बोल सकते हैं. If you put this value in meter, then it will be meter per second. If you put this value in centimeter, then it will be centimeter per second. So this is how you can find out. Now the last question is angular momentum. देखिए angular momentum एक ऐसा टर्म है which does not depend on Z. Okay, it is only depend on N, because you know angular momentum जो था that is L, or you can write mvr, that is equal to N into h upon 2 pi. Now here what is N? If it is third orbit, then it is N is equal to 3. So here N is equal to 3. So it is only depend on N. So L will be 3h upon 2 pi. Now you can put the value of h and pi to find a numerical value. Okay, otherwise you can write in this way also. So it will depends on the question. If it is MCQ question, then the format of the answer is in this way in terms of h and pi, then you can find the answer. Otherwise, if they gives numerical value, then you have to put the value of h and pi. Okay, so now move to the next question. So what is this question? Find this question. A doubly ionized lithium atom, again here lithium is given. So doubly ionized मतलब lithium plus 2, पहले ये देखना पड़ेगा. lithium plus 2 के लिए देखिए Z क्या है 3 है. So पहले हम ये निकाल लेते हैं. So a doubly ionized lithium atom is hydrogen like with atomic number 3. ओके, दे दिया ये. फाइंड द वेवलेंथ ऑफ रेडिएशन. सो आपको लैम्डा निकालना है. रिक्वायर्ड टू एक्साइट द इलेक्ट्रॉन इन लिथियम प्लस फ्रॉम द फर्स्ट टू द थर्ड बोर ऑर्बिट. सो इफ दिस इज द फर्स्ट बोर ऑर्बिट and this is the third Bohr orbit, then you have to find out the wavelength and find the wavelength of the radiation required to excite the electron from this to this. The ionization energy of the hydrogen atom is given 13.6 electron volt. मतलब ये जो energy expression है we can write in terms of 13.6 electron volt. Now what is the energy difference if this is the E1 and this is E3? So we have to find out E1 minus E3, then we will get the energy difference and from where we can find out the wavelength. So पहले हमको क्या निकालना है E1 and E3 for lithium. But what is the general expression of N? En. So En is nothing but in terms of hydrogen atom we can write minus 13.6 electron volt upon N square into Z square. This is in terms of electron volt. Z here is 3 and N is the first for first ground state En is equal to 1. So you can write down here E1 and that is equal to minus 13.6 upon 1 into Z is 3, so it will be 9 electron volt. Now if you calculate this, we will just get minus 122.4 upon 1 electron volt, that is basically minus 122.4 electron volt. Now what is E3? Again if you put the value here, so it will just minus 13.6 upon 3 square into Z is again 3 here for third orbit, so it is 3 square, so it will be cancel out, so it will be just minus 13.6 electron volt. So this is the energy for the first excited state and this is the energy for the फर्स्ट एक्साइटेड स्टेट बोलने की कोई जरूरत नहीं है. दिस इज बेसिकली ग्राउंड स्टेट एंड दिस इज बेसिकली द सेकंड एक्साइटेड स्टेट. ओके, E3 का मतलब होता है सेकंड एक्साइटेड स्टेट, बट यहाँ तो लिख ही दिया है कि फर्स्ट टू थर्ड ऑर्बिट. अगर ऐसे भी बोल सकते हैं कभी कभी कि ग्राउंड स्टेट टू सेकंड एक्साइटेड स्टेट. तो ग्राउंड स्टेट मतलब है n = 1 और सेकंड एक्साइटेड स्टेट है n = 3. फर्स्ट एक्साइटेड स्टेट जो है दैट इज n = 2. ओके, so you have to keep in mind these things also. Sometimes you should understand the language of the problems also. Okay, so this is E1 and E3. Now what is the energy difference delta E? First you have to find out which energy is greater. You can say this energy is the greater energy because the negative value is less than this, so this is greater energy. So delta E is nothing but E3 minus E1. So what is E3? E3 is your minus 13.6 and that will be minus plus 122.4 electron volt. So that will give you 108.8 electron volt. So this is your delta E. Now how can you find out lambda? So you know delta E या फिर E2 minus E1 या फिर E3 minus E1, that is basically equal to h nu, and nu is equal to c by lambda, that also you should know. So this is hc upon lambda, that is equal to 108.8 electron volt. Now from here you can find out lambda. Okay, so if you write energy difference in electron volt and lambda in angstrom, then hc का जो वैल्यू है वो हमको पता है. hc का जो वैल्यू होता है 12375 when lambda is expressed in angstrom and energy is expressed in electron volt. ये आपको याद रखना है for simple calculation. Okay, so from here you can find out lambda. So lambda angstrom is nothing but 12375 upon 108.8. Okay, so it will come in angstrom. So the value of this will be 113.74 angstrom. So this is the lambda. So this is the result which asked in the question. Okay, so find out the lambda for the radiation. So this is how you can solve these kinds of problems easily. Okay, now we'll solve another more problem. So this is just you have to find out a mathematical expression for time period and angular speed. So find the variation of angular speed and time period for single electron of hydrogen like atom with n and z. So we have to find out the dependency of angular speed and time period in terms of n and z. So you know angular speed का जो definition है that is omega is equal to v upon r, where v is the speed and r is the radius, and time period जो है that is t is equal to 2 pi upon omega. इसका मतलब अगर हमको ओमेगा मिल गया तो t आसानी से मिल जाएगा. Now to find out omega we have to know about the dependence of v with n and z. So we have solved the problem by using the expression कि v is proportional to z upon n. Okay, and similarly r is proportional to n square upon z, n square upon z. So now if you write here you will get just v omega is equal to, so v is nothing but z upon n. You can write here proportional. So omega is proportional to z upon n square upon z. So what it will get? It will be just z upon n into z upon n square. So it will be z square upon n cube. So if you want to find out the dependency of omega with z and n, so this is just proportional to z cube upon, so the z square upon n cube. So this is, now if you want to find out t, so t is equal to 2 pi upon omega, so which is obviously t is proportional to 1 by omega. So if it is proportional to 1 by omega, then it will reverse reciprocal of this, so t will be just n cube upon z square. So sometimes these kinds of expression are also used in some problems. So you should know how to find out omega and t from the basic formula for basic dependency of omega with v and r and dependency of v and r with n and z. So this is how we can find out the dependency of omega and t in terms of z and n. And sometimes directly we can solve the numericals by using this expression if you can remember this expression. Otherwise you can easily derive from here. Okay, so this is how you can solve the simple problems which can arise from these topics. Okay, so लगभग ये कंप्लीट हो गया पूरा चैप्टर अकॉर्डिंग टू आवर सिलेबस. एंड जो प्रॉब्लम्स न्यूमेरिकल्स जो आते हैं एग्जाम में ऐसे ही आते हैं, इससे भी इजी आएगा. वो डायरेक्ट डिपेंडेंसी पूछेगा, कभी कभी n का वैल्यू दे देगा और वो पूछेगा कि व्हाट इज द रेडियस ऑफ थर्ड ऑर्बिट, व्हाट इज द रेडियस ऑफ फोर्थ ऑर्बिट. ऐसे बहुत सिंपल क्वेश्चन एग्जाम में आता है. फिर भी मैं थोड़ा सा अच्छा 2-3 क्वेश्चन सॉल्व करवा दिया. लगभग पूरा कॉन्सेप्ट आपको क्लियर हो ही गया. सो इफ यू लाइक दिस वीडियो, सो obviously comment on the comment box and subscribe the channel also. Okay, thank you.